Hello guys, do you remember last time we covered in my last video how to build yourself an electric vehicle, how it works. So as you remember we made this video and we used a controller. The controller that that was able to switch the direction of the current very quickly. These our muscles, the relays. I'll take this. Yeah, these our muscles. They were needed because the motor is powerful. Our motor is powerful, and this guy is weak, and it's not able to control the motor directly. That's why it sends signals to muscles, and the muscles gave the big current to the motor and took it back to the ground. Depending on these muscles, which one was open, the current went from the top to here to one of these three phases, and it went to motor, and it returned from one of these three phases depending on the second part, which one of these three relays were open at that same moment. So we needed one open relay at the input of the motor, and we needed one open relay here, one of these three at the output of the motor to provide the path for the big current to reach the ground. So the function of this controller, why we needed controller, because we couldn't do it by hand. We couldn't switch all this. We had pins, PD0, PD1, PD2, PD3, PD4, and PD5. These 6 pins must be 1 or 0 in different times. So we just needed to switch them very quickly in the right moment, so that would the current would come to the motor by 3 of these phases at the right time. As you remember, these were yellow, green, and blue phases, and it must leave the motor at the right, for example, at the right phase at the same time. So, for example, we put one here. That means that this relay would provide path for escape, and we put, for example, one here and the 5. By doing this, we would provide path for the big current, that it would flow here, and it has nowhere to go, just one path. Here it has no choice, so that it would be green phase, that it would go into the motor. And where does it go? By which path does it go to ground? By this path, because we have opened this by providing one here. Open this relay supplied path to ground from the motor. Yeah, it would be green in and blue out. But you can watch that in the previous video. But why do we need controller at all? It had two main functions, as you remember. One of these we had covered in previous video. It's switching these relays, these muscles, at the right moment, depending on the state of the Hall sensors. And these Hall sensors states were like in this table, as you remember, 110, 100, 101, 001, 011, 010. That's 6 states, 6 positions of the magnets, and after this all repeats, all these 360 degrees that the motor would rotate, and all the time repeats all these positions one by one. All these combinations of ones and zeros, they repeat. These are output of the Hall sensors. As you remember, that the Hall sensors, we have 3 of them, 1, 2, 3. They turn on depending on the magnet under them. Either this is south or this is north. This is north or this is south. So it gives 1 or 0 to the output, to the here Hall sensors. So we have this pin, and this pin connected to the Hall sensors, 3 of them. And these are listening port of the controller. It listens to them, and it gets 101, 110, 001 all the time. All the 6 combinations, then they repeat themselves all the time. That the motor turns, these combinations repeats, and depending on this, which combination present at the present time at these pins, the controller decides which of the pins of the port D to turn on, to send ones, which to turn off, to send 0. So as we can see, this is question and answer logic. This is very simple. The motor questions, sending the combinations of ones and zeros by using Hall sensors. So the question is present at the Hall sensors, and the answer goes to the relays here. Just like in this table, we have questions and we have answers. So this question goes into controller, and controller gives answer to port D. And this simple logic, we don't need controller for that. Why? We don't need to learn how controller works. We don't need to learn programming at all. We don't need to deal with controller. All we need is just a simple memory chip. But the second function of this controller was speed control, that it would provide a little bit of buffer, where we don't have full speed at the motor. As you remember, this buzzing that you switch on the throttle button, that will you start moving on your electric vehicle, then we had this buzzing sound coming. That where we had 100 hertz of this switch turning on, turning off, and that was programmed in the controller that we would not send the 100% of power to the motor at once. That it would a couple of seconds, maybe 3 seconds or 4 seconds, we would have, for example, half the power going to motor. And the main function of this controller was to switch to answer the questions of the Hall sensors, and the second function of the speed control. So I have I've figured out that we don't need actually a controller. This, instead of controller, in these schematics I have a memory chip, and this memory chip is the same way connected to Hall sensors, connected to address pins of the memory chip 1, 2, 3. Oh, sorry, not 1, 2, 3, but 0, 1, 2. These address pins are used for listening, just like in controller example. They listen to address, and when we get the address, they give an answer who lives by that address, and by that address we would accommodate the residents, which are bytes, ones and zeros. Depending on the input, we'll give the right output, just like here. At this address 110 leaves byte of data 100001. At this address leaves this byte, and 6 altogether, and we don't need anything other than that. Memory chip is like a book. It has page numbers, which are addresses, and it has content of each page, which is byte of data. I had one video which explains how it's made, this chip, parallel EEPROM, this, and how to program this by hand. It's very easy. These 6 bytes is not much to program. Just like in these cards, we have these addresses. You see these ones and zeros, that's binary logic. We, in our usual life, we use decimal logic, and we can translate binary logic to decimal logic. For example, that 001, that's 1. If we take a look at the calculator, we have binary, we have decimal. Well, for example, who lives by address 1? That 1 means 1 in binary, 1. 001 means 1 in decimal. Who lives by that address? Memory chip takes address, sees that somebody asks who lives by that address, Hall sensors asked, and memory chip looks, at this address lives this byte, and it sends these bytes, to the former port D. Remember, port D is connected with relays with our muscles to turn them on. These flashing, these light emitting diodes would flash and provide path for the big current to flow. And so we had port D, but now instead of port D we have IO and this from IO0, IO1, IO2, IO3, IO4, and IO5. These 6 outputs give us exactly what we had with controller. So we provide address and we'll get the correct byte. And so we can turn the same way these relays one by one using this memory chip instead of controller. We don't need controller. But how do we control the speed? If we have our electric vehicle, for example, this electric scooter, we have main power, we have a speed button, and this already doesn't have controller. It has memory chip. Just it's made by that diagram, just like we saw a few moments before. And so when we turn it on, press the power button, what happens? You see, you hear the wheel is spinning, but what happens here? The power from the battery goes to the motor, but not 100%. It goes to the resistor, and some of this power dissipates. Some of this power turns into heat, and this resistor burns some of this power, and the remaining part goes to the motor. So that when we start the electric vehicle, then some of the power is wasted, and the remaining part goes to the motor, so that the start of this vehicle would be slow, that it would be this mild. And when we gain some speed, then we would press this button, what this button does, it makes short circuit between input and output of this resistor, so that this resistor would not waste power anymore. That the power goes, 100% of the power goes to the motor when we press this button. We press it only then when we have some speed, initial speed, so that our process would be mild and nice, that gaining speed would be nice. So that's the logic how it works. Instead of the controller, now we have a memory chip, and the speed control is done. By default, this power resistor dissipates some of the power, wastes it to the air, and the rest goes to the motor. And when we press the high speed button, when we get some speed already, we're pressing the high speed button and it short circuits the resistor. It no longer functions. It provides all the power from its input to the output. Well, this here to provide default value. Default value is 1 in our case. So this resistor here, to provide default value to output, to enable, these outputs of this memory chip is not always enabled. It's enabled only then when we press the throttle button. Now let's see. When we press the power switch, the main switch is here. The lamp starts working when it gets power. And when we press the power switch, that's throttle, you see the throttle, then the power goes to the relays and to the motor. But it goes only then when we send once, or when we send one to one of these relays to provide path to the motor, and when we send one to one of these three relays to provide a path from this same from the motor to the ground. We need to send one to one of these three, and we need to send one to one of these three in order to the motor to be spinning. But when we just turned on the power, then we don't want this chip to give answer. This because we already have some value at the Hall sensors, but we don't want this chip to answer straight away, because we don't want this motor to work before we press the throttle button. But when we press the throttle button, what happens? Then output enable pin, it was 5 volts because it was pull up resistor here that pulled up to 5 volts, the default value. And now it gets connected through throttle button to ground, and that would be grounded, output enable. And when it is grounded, that means that this output of this chip is enabled. That straight line over the pin name means that it's enabled when it's grounded. So it's disabled all the time except when we press the throttle button, then it's enabled. When we press the throttle button, then it's enabled. Other time it's all the time 5 volts, it's all the time 1. Yeah. And when we press the high speed button, then this resistor, this power resistor, it gets shorted, it doesn't work anymore, and the current doesn't go through that resistor, it goes through high speed button. It bypasses the power resistor, and so we get the full power to from the plus to it goes here to the motor. Yeah, that's how it works. So we don't need actually controller, we don't need to learn controller, we just need answers to our questions, and that's all what we need, and some speed control, of course. So you can build yourself this electric vehicle, you can build electric scooter or electric car. Be careful, there's a much more power to deal with. Yeah, and the values which work with my scooter, with my electric scooter, this big R, this is our 0.5 ohm, that's half an ohm resistor, power resistor, 600 watts. It's such square one. It's not heavy, it's about maybe 60 grams, I don't know. And these 4 resistors, these are usual 2 millimeters maybe. These are not required to be powerful. And all the rest is the same like we covered before. there's no difference. So yeah, let's see how it works. nii, olime nüüd õues ja paneme tööle, siis hakkame vaikselt sõitma. Ma vajutasin gaasi nupule, nüüd vajutame kiirendamise nupule. Päris hästi.